All right, go ahead and get started. There's a lot more people than I expected, so thanks everyone for coming. I know it's a little bit early. So this is a talk titled XR Graphics in Unity, Maximizing Your AR/VR Experiences Potential. My name is Dan Miller. I work for Unity Technologies as an XR evangelist, focus a lot on augmented and virtual reality. If you guys are interested in anything that you see in this talk, as well as just general Unity and AR/VR focused content, you can follow me on Twitter down there. So what I want to do is kind of give a brief update on some of the things that we've been working on with augmented and virtual reality. Some of this is going to be based on what we call our virtual reality kind of best practices or graphics best practices. There's going to be a little bit of up-to-date on some of the things we've been doing with the scriptable render pipeline, and we'll be kind of describing how you can start to take advantage of the tech that Unity is building for your experiences. So the first part of the talk is going to be mostly focused on virtual reality, considering things like stereo rendering methods, as well as some of the new scriptable render pipelines. After that, we'll be going into augmented reality, talking a little bit about some considerations for mobile as well as head-mounted, and then I'll be showing a small demo that I worked on, kind of showcasing how you can kind of iterate and improve your rendering in AR. All right, so the first thing I want to talk about is just stereo rendering. What do we have support for? How does it work in Unity? What are some things to consider? So when we first started implementing stereo rendering for VR headsets, we used what we call multipass. And this is a way where we're kind of traversing the scene once for each eye. Now, as you might expect, this isn't very optimal. And really, you're kind of, what's on the left eye, the object's there, what's on the right eye, and then combine those together. Kind of the two-camera method. How we've iterated on that is what we call single pass, which actually is much faster. It only goes kind of through the scene graph once, is able to kind of look at some shared data. And then what we've also iterated on and what we're kind of trying to suggest as the most optimal solution is something we call single pass instancing. So this is the ability to kind of have each eye texture in a specific array. But the big thing to consider here is that this isn't actually supported on all platforms. Where it is, we definitely recommend it, but there are some kind of considerations when you're doing things like custom shader development and other things to consider how this works. And usually what we suggest, if you're seeing something like post-processing isn't quite working yet correctly, you might try kind of changing some of these rendering methods to see what is working, what isn't, and that might lead you to some clues on how to get it working properly. So there's a couple things you have to do when you're kind of changing your Vertex shaders in order to start to take advantage of these stereo rendering methods. Out of the box, things with a lot of Unity's built-in shaders will just work. But if you're doing some custom effects, you're doing something special with, let's say, water or something like that, you're going to have to go in and kind of add some macros to your shaders. So what does that look like? So here's kind of a basic Vertex shader here. And what you need to do is you need to basically start putting in, there we go, these different macros kind of at each level. And what this does is this kind of tells the shader specifically, it's able to start to kind of understand that it's, which eye it's being rendered for and things like that. So first in the app data, we're putting that in. And then in the struct, we're basically telling it to output to the stereo. And then finally down there in the Vertex shader, this is where we're kind of setting and passing in which eye it's being rendered to so that it can start to take advantage and render for these new stereo methods. And now I want to talk a little bit about RenderScale versus RenderViewportScale. We've had a lot of kind of confusion about when to use these, what they do, and kind of how they work. So I'm just going to kind of briefly describe that. So first of all, with the kind of latest iteration of the APIs, we've actually renamed RenderScale to be Eye Texture Resolution Scale. And really what this does is this controls the actual size of the texture that's being rendered to each eye. And where you might consider something like this for either kind of up-resing it or down-resing it by changing the value above or below 1 is if, let's say, you're porting kind of a high-end VR experience to something like a standalone platform. You might be able to kind of adjust this value a little bit just to get some extra performance when you're going from something like 90 frames a second to 72. Now, RenderViewportScale is actually a a similar result, but it works a little bit differently. Instead of scaling the texture, you're just scaling the viewport, as it suggests. And the big thing for this is that this is something that you can actually use dynamically in your experience. Let's say you have a part in your game or experience that's really kind of graphically intensive, maybe it's a big explosion, something like that. You can actually use this to kind of down-res it a little bit, maintain perf and performance as you go through that experience, and then up-res it back after so that you're seeing the same kind of scale and quality. So eye texture resolution scale is kind of something that you'd probably set once and isn't really performant to update at runtime. Render viewport scale is something you can modify at runtime, but just consider it for kind of special use cases or when you might need it in your application. So now I want to talk a little bit about HD render pipeline for virtual reality. So this stands for high definition render pipeline. And if you're not familiar, Unity is kind of evolving its rendering tech using what we call scriptable render pipelines. So it is supported in 2019.1 and beyond. And this allows you to go in, take any project in 2019 using the high definition render pipeline and simply enable VR like you could before in all of your legacy or other projects. Now in 2019.1, we have the support for single pass stereo. And in 2019.2, we're able to support single pass instance. So this is really the optimal path. And when you're pushing kind of the visual fidelity of something like this, it's really important to try to optimize at every step. Now, the unfortunate part is that there are some things that aren't supported for virtual reality. So, for 2019, we're looking at things like single pass instance, tile lighting, deferred, volumetrics, VFX graph. But that's actually just in 2019. And in 2019.2, we're actually basically supporting everything that's available in the HD render pipeline, except the VFX graph. So there's a known bug there. It is being fixed, and it's actually available in 2019.3. So if you're excited about using the high definition render pipeline, we definitely recommend checking out the latest alpha that's out for that. And you get access to all of the really cool features available in the high definition render pipeline. This is things like subsurface scattering, volumetrics, and really just the high-end lighting and rendering. Now, that's not to say that some of these things are going to be more expensive than others. So you really have to kind of consider how you're using them in your experience and what hardware you're running on. So now I want to talk a little bit about universal render pipeline. So if you've been kind of following the tech and how we've been evolving it, this was referred to as the lightweight render pipeline. And now we're kind of, let's say, rebranding it to be more focused in kind of the evolution of how rendering works at Unity. And with universal render pipeline, the goal is that we support all of the platforms that Unity supports. So this is everything from console, obviously, up to VR and AR as well. Now, it is also supported in 2019 and above. And in the kind of last benchmarks tests we're getting against the legacy renderer to the universal render pipeline, we're seeing an almost or greater than 25% increase in performance. And that's just out of the box with kind of certain lighting setups and things like that. Now, there are some kind of things to consider there. We do have certain optimizations for virtual reality in the universal render pipeline. But because it needs to support all the different platforms, it is kind of still a work in progress. And there's some things to consider with stuff like multi-sampling, anti-aliasing, as well as post-processing. With the high definition render pipeline, when we got the single pass instanced working, it allows for the post-processing to be much more straightforward. Instead of trying to post-process one eye and then post-process another and kind of match them back up, we can just do it on that single texture or those single textures in the array. And so right now, we kind of have the single pass, or what we call the double wide, which kind of limits some of that support in virtual reality for the universal render pipeline. Now I just want to talk a little bit about post-processing. So a lot of people always come up and say, things are looking great. I really need this bloom effect, or I really need this color grading and things like that. And really, we always kind of suggest a little bit of caution when using post-processing, especially when you're looking at things like mobile platforms. they're really limited, and it can sometimes be a challenge to really hit performance. And post-processing is just going to be an expensive process on top of that. The other thing to consider is that certain post-processing doesn't necessarily feel right or isn't appropriate for things like virtual reality. You're talking about things like depth of field, where you're kind of controlling the blurriness of what someone's looking at. That can be a little bit disorienting at times. And as mentioned earlier, if you are running into certain issues with either certain effects or certain processes in the post-processing, definitely kind of cycle through the different stereo rendering methods. That might give you a little bit of idea of what's going wrong and how you can fix it. And lastly, I just want to mention briefly for augmented reality, when you look at things like a mobile device and using AR on that, you have to really think about what post-processing you're using and how it affects it. So for mobile devices, the post-processing goes basically, in post after everything is being rendered. So that's both the camera feed and your digital objects. So if you do something like bloom, now your entire camera feed gets bloomed out, and it can kind of take away from the experience. It doesn't necessarily work just on your digital content. All right, so now I want to talk a little bit about augmented reality. This is something I've been focusing on more recently, especially on the mobile side. And so I hope to kind of share a little bit of tips and then show you guys a quick demo of some of the stuff that I worked on. All right, so with augmented reality on the mobile side, a couple things to kind of keep in mind. First of all, your users are going to be kind of using your content wherever they are. Now, you obviously can think about things like the certain environment, and as you test it, it might look good. But you can see things like this where the person's actually walking through the content. And so things like shadows as well as occlusion aren't necessarily provided out of the box, and you don't really get those for free. So there takes some extra considerations if you are considering implementing something like that. The other thing is just the way the rendering works is that it renders the camera feed and then the digital content on top of it. For things like the universal render pipeline, we do have support for that in mobile augmented reality using AR Foundation. Now, with the upgrade to the universal render pipeline, it's still a bit of a moving target. So we are kind of working on getting that support as the universal render pipeline gets released as well. The other thing to keep in mind with head-mounted augmented reality, so this is things like the Magic Leap or the HoloLens, and these actually use additive displays. So that means you're looking at a kind of transparent display that's adding light in. And what that means is that as you kind of do things like physically based rendering, you can see the sphere there on the far left. What happens is that your objects go from somewhat opaque down to transparent, because all blacks and dark colors are rendered as transparent. So something to kind of consider there is something I really enjoyed here is the Magic Leap samples actually ship a special shader that kind of does the opposite of what you would see in physically based rendering. So instead of going from light to dark, it actually just puts a light at the top of it, and you can see it a little bit more in the other sphere there. And that allows you to kind of maintain your opaqueness that you want in your holograms throughout your experience. With the universal render pipeline support, it is supported in the Magic Leap, as well as coming to the HoloLens. And there are some kind of considerations there of which stereo method is supported. And we're currently fixing the stereo rendering bug for things like the VFX graph, which will be enabled in the future. Now, things like occlusion. So a lot of the times, especially when I was kind of first starting out with some of this technology, is that the things felt great. I was able to place content in the world, but then you'd have someone kind of walk in front of them, or it wouldn't certainly look right, and it kind of breaks the illusion a little bit. So in Unity, we actually originally shipped a occlusion shader that comes with our ARKE plugin, and that's that shortened link there. Is just a gist that I posted. And what that allows you to do is this is a shader that you can really apply on any digital objects. So the common use case was to kind of apply it to found planes. So if you were to kind of scan around your environment, if I were to place an augmented object down there, and then I detected a plane up here, I could use this occlusion shader to actually occlude the object behind the podium, but it requires some of that kind of pre-scanning. You can also do things like using feature points, which are found much quicker to planes than planes, and kind of spawn little occlusion objects from there to get some quick occlusion in your application. And then last but not least, there's also some built-in occlusion for certain platforms and certain features. So if you're talking about things like head-mounted AR, Magic Leap and HoloLens have the full kind of world meshing, and they can occlude objects behind that just with some of the features that they ship. And here in the latest ARKit 3.0, Apple implemented the ability to occlude objects behind humans. So that little Bauhaus structure there is a piece of digital content, and that's me kind of slowly walking in front of it. And you can see I'm using my body to actually occlude the object there. So the next thing I want to talk about is shadows. This is something that I'm really kind of passionate about. I try to keep and consider in a lot of my AR projects. So similar to the occlusion, we originally shipped a shadow shader that came with our ARKit plugin. Now, what this does is this actually allows you to render shadows on transparent geometry. So what that looks like in Unity is kind of what you're seeing in this small GIF over here, where basically I have digital content, I've placed a plane underneath them, and I'm using this shader to apply shadows to that transparent plane. And now you can see we're actually getting kind of accurately shaped shadows around these digital objects, and it really just grounds them in the environment much more. Now, one thing to keep in mind is that with Unity, a lot of objects and a lot of features, such as shadows, lighting, physics, navigation, really want you to kind of maintain what we call this 1:1 scale. So everything is, 1 unit in Unity is 1 meter. So if you spawn a cube, you can kind of see it's sitting there. But a lot of augmented reality, especially on kind of the mobile side and head-mounted, is they want this more small diorama. So you want something on your coffee table rather than, a life-size buffalo or giraffe. And in order to achieve crisp shadows with that, you actually have to kind of scale your rendering down. So, Unity is expecting a cube that's a meter size. If you put a cube here that's just a few centimeters, then the shadow isn't going to be as crisp as it is at that larger size. So in Unity, what you can do is you can actually scale the camera parent, and as you scale that up, it inversely scales the rendering of your content. So if you wanted to kind of convert a meter down to a centimeter, you could kind of scale up your parent object over the camera, and then that's going to scale down the rendering of your cube and allow you to maintain crisp shadows at kind of different scales. And I found that does kind of take a little bit of playing around with, kind of understand the scale that you're going for. And last but not least, I always recommend considering blob shadows. So this is like a mobile game technique where you just have a shape of the shadow kind of as a sprite underneath your objects if you're looking at kind of static content there. There's also some platform-specific features. So I talked a little bit about occlusion, and one thing that I've been kind of playing around with a lot recently is environmental probes in ARKit, as well as environmental HDR in ARCore. So these are platform-specific features that allow you to just understand more of the environment that you're in. We're talking about things like what direction the light's coming from, being able to reflect the real world on your digital content. And these are just a couple things to consider as you build up some of your experiences. All right, so now I just want to show a really small demo here. Let's see if I can. All right. All right, that's me. All right, so what this is this is just kind of a small demo, and I'm going to go and kind of spawn Adam here. See if we can get some tracking. And there we go. So by default, this is Adam. Now, he doesn't have any materials. This is kind of just colored materials on him. He doesn't really have things like a normal map. And so what I have here at the bottom is just a couple things to start to kind of enhance the rendering and make him feel a lot more like he's really here on the stage with me. So the first thing I can do is I can add a shadow. And so that's using the shader that I mentioned earlier, where it's actually rendering there on a transparent plane. So we can kind of turn that on and off. And you can see that it's accurately shaped around him. Now, it is just falling off the stage. There's not really any considerations for that right now. And then the next thing we can do is just add his materials. So he has some really nice materials. You can see there's things like a normal map, as well as certain textures for his kind of front plate monitor there. And then from there, we can start to add these different features that are kind of core parts of the AR kind of mobile SDKs. So the first thing here is that's the environmental probe. So that's actually now kind of looking at the environment that he's placed in and kind of shading him towards that. We can also turn on lighting. So this is the ability to kind of darken or brighten your augmented objects here based on the kind of ambient intensity of what you're seeing here in the frame. And lastly, we can kind of do a little bit of post-processing and color grading here to really kind of match him with the other parts of the scene. So just to kind of toggle all of this on and off. So here's how we kind of spawn him with not all the maps and textures or the features. And there's kind of the achieved result there, building that up. All right. So again, just kind of breaking down what you saw there. When we first spawn Adam, he's just using kind of colored materials. And then we're applying the different maps that come with him. Now, if you're not familiar, Adam is a character built by Unity. He's been included in kind of our cinematic universe. And he is freely available on our asset store if you're looking to kind of play around with this as well. So he has different maps for specularity, normal, and occlusion. And that is obviously a big jump up from just the colored materials. From there, I'm using the environmental probes. Since I'm on an iOS device using ARKE, we can now basically kind of capture the environment that he's in here, use that as a cube map, and then apply that to a reflection probe in the area that he's standing. After that, we use light estimation, and that's going to kind of dim or brighten him depending on the ambient lighting in the environment. And again, these are kind of small steps towards making him fit and feel a lot more integrated in. And last but not least, there's just a small post-processing. And I am using color grading here just to kind of accurately match what he looks like with the background and things like that. Now, I'm certainly no color grader. I just kind of freestyled this. So there's potentially a lot more you could do to make him feel a little bit more integrated in the environment. But to me, this is kind of the kind of steps you would take and consider as you start to build him up. And I've also included the shadow in there. And that just, again, kind of grounds him a lot more in the environment. All right, so that's pretty much it for my talk. Thanks, everyone, for coming. And I think we have a couple minutes for questions. And I'll basically be hanging out at the booth along with a lot of other staff at Unity. So definitely come by and check us out. So the question was, are these slides available? They're not currently, but you can find me after or shoot me an email and I will give them to you. Any other questions? The question was, can I see your email again real quick? It is up there. Any other questions? Yeah, so the question was, if there's a depth sensor on your color, or on your, in addition to the color camera, can you use that to kind of render things at further distances and potentially use occlusion? Right now, a lot of the stuff that we're doing is just reliant on the current kind of platforms and tech, but I imagine that if there are depth sensors in the future, it's definitely something to take advantage of. Question? Yeah, so the question was what factors was I looking into when doing the color grading there in the AR example? And to be perfectly honest, I basically just freestyled it and chose a couple different settings. It is using a LUT, and that's just part of the post-processing stack that we offer. So I just kind of grabbed one of those, adjusted a couple of the values, and really, because the post-processing works on the entire camera feed, it kind of, off the bat, allows the digital content to blend in a little bit more, rather than kind of being rendered completely different. Any other questions? Yep. Yeah, so the question was, with the reflection probes, were they done at startup or were they dynamically animated? So the way the environmental probes work is that you have the ability to automatically place them. So as you kind of move around the environment, they'll place them and then grow as they understand more. Or you can place them manually. So I'm actually placing them manually, where I say, Adam, stand there, and then place the environmental probe right there. Now, the way it works with environmental probes is that they do slowly update as you start to understand more information about the scene. So you might see some kind of flickers or changes there throughout your experience. Yep. Yeah, so the question is, would you export your digital content out, and what kind of file would you need, or how would you do that? It really depends. I'm kind of exploring some things right now with the ARKit 3 body capture. And really, at the end of the day, this is a Unity app running on device. How or what you do on there, whether you're kind of caching animation data or you're kind of rendering frames or kind of recording from the screen, is up to you. I know for a lot of my content, I'm actually just using kind of native screen recording and then bringing that back in. But potentially I could put Adam in a green space and put my digital content in a physical kind of green room and then output them from there just from a video. I think we have time for one more question. Yeah, so I mean, AR Foundation and a lot of these features that I actually showed there on the final AR demo are available. There's nothing really restrictive. The environmental probes were added in AR Foundation 1.5, which is available in the 2018 version. A lot of the new rendering stuff with the high definition render pipeline and things like that, as those evolve, those are kind of pushing the limits. It's certainly something we're thinking about with kind of backporting and stuff like that. All right, thanks. I'll be around the rest of the day.